Hello everyone, welcome to Caution Tape's Building Fundamentals and Secrets. Sorry we couldn't have the live stream working. We had a couple of technical issues. So we are recording it now. So yeah, without further ado, let me call in Tyler from A39A. All right, how you doing, Tyler?
Good.
Good, okay. So tell us what we're gonna be running through today. Yeah.
For the first fundamental we're gonna be doing is friction. Here I made a 3:1 gear ratio to a wheel. Today I'm going to be talking about if a gear or sprockets are faster.
This is for me?
Yeah.
Okay, and what are we doing here?
So we're going to spin it by the gear or your sprocket.
Sprocket, okay.
And then we're going to spin it, and whoever's wheel will last the longest will be the winner.
Is the winner?
And that's how you can tell if a gear or a sprocket has less friction.
Okay, and then you put spacers and washers around sprockets and gears, okay. Let me check yours.
Mine just says washers.
Okay, cool. So you know you're not sabotaging me in any way. Okay, cool. Ready? So you want to count down? 3,
2, 1, go.
Ooh, okay. A lot longer. All right. So all right, I don't believe you in one. Let's do best of 3.
Okay.
Ready?
3.
Count down again.
2, 1.
Okay, one more.
3, 2, 1.
Okay. So gears seem faster, and why is that?
Because for one is sprockets have more natural friction, and gears are better when they're closer together. But for sprockets, when it's at a long distance, it'll be better. Because when you use too many gears, it loses power throughout as many gears. So if you add one more gear, then you lose power. Every time you add a gear, you lose your speed or torque.
Okay, cool. All right, so gears over sprockets when it's, let's say for a drivetrain.
Yeah.
But then let's say if I want to make an intake, I'd want to use sprockets because it has a weird spacing?
Well, for sprockets are much easier to use or more flexible to use. So if you want to adjust your positioning on your robot, so like you want to play with it a lot, moving it down and up, that might be better if you want to do it that way. But if it's like a close distance and your motor's like right beside your intake, then you might just want to use gears because then it would be more direct than this.
Okay, now I have a question. What about pulleys? Because we know that the Fling HeroBot uses pulleys for the intake. Is that good or bad?
Pulleys for the intake, it doesn't have as many sizes, and it doesn't have like a grid thing right here. These things, those.
The holes. Okay.
Yeah, the holes. And it's harder to connect, what do you call it, standoffs to go across, and it won't be as stable, so it'll bend in if you add more elastics.
Okay, all right, cool. Okay, so what's next?
Oh, I forgot to mention, for when you make a drivetrain or one of these things, always add either washers or spacers. For gears, for drivetrains, I would recommend using one washer on each side because washers reduce friction. For sprockets, you have to use a spacer, 2 spacers, one on each side, in order for it to not scrape against the beam.
Okay, and washers again are the thin ones, and spacers are the bigger ones. Okay,
yeah.
Cool. And just to reduce friction, and that is right?
Yeah.
Okay, cool.
Now I'm going to teach you how to build a proper robot.
Okay.
We're going to be making a 2:1 gear ratio drivetrain, and this is based off of a prototype we built this year. So let's begin. So first we're going to get a 1x18 beam. Okay. And then 18 beam. And then we're going to use the cap shaft here, but make sure you don't use this inside of the motor because it's a little narrower and it'll break off inside of the motor because of the power it has. I would recommend turning it so that this part is right here, like this. So this is not inside the motor, but it still can't come out of the
Okay, so it's fit like this.
Yeah.
Okay, and then the red divider is on this side. Okay.
Yeah, on the other side.
What's next?
And then for this, if you want to reduce the friction, you're gonna put the gear in first, like that. And then since it lines perfectly with the little top of the gear right there, we're gonna add a washer on top of it because it's flat, just like that. So we add a washer and then we put it on. Then we're gonna add another washer, just like that.
Okay. So right now we have we have the red divider, and then we have a washer, 24 tooth gear, and then a washer. Okay.
Yeah. So and then we're gonna do the same for the other gears.
So you're putting washers everywhere. Would you say this is one of the secrets to Moonwalker? Is that why you were so quick?
Yes. Washers reduce friction and it makes your robot a lot easier to move, and it doesn't create as much strain on your battery.
Okay. So now you're using different size motor shafts. Why is that?
We don't have the part.
Okay, so we don't have that many motor shafts. Okay.
They're expensive.
2 come in a pack, right? Okay. So it shouldn't matter what size you use as long as your drivetrain can accommodate for it, right?
For your drivetrain, you'll probably want to use the shorter one, but we don't have that anymore left. So I would recommend using this for all of them. For that.
The shorter one, okay.
Yeah.
The red one. And after you built your first hero bot, how long did it take you to realize washers are the key to gearboxes?
Well, for the principle, it's really that washers would reduce friction because when you put a gear in with the one standoff, it'll still like move around a lot and
wiggle around. Okay.
Yeah, and sometimes if it wiggles around a lot, it'll hit the beam, or this for gears it becomes like one with the beam kind of. So like there's a little lip on it, and then it like touches it a lot. So it's better to use washers because then it
quickly
goes
show
around.
the camera that. So grab another beam. Maybe show that again.
So this is with no washers. It would.
So this is
rub
the main
against
reason
it.
why you have washers, is because how the VEX beam is designed. It has like this lip, right?
Yeah.
Brim, you would call it.
Right there, it's touching right there. You can see it flat against that, and that would create a lot of friction.
Okay.
So to reduce friction, we use washers because then it elevates it above that lip just a bit, so it's not touching it.
I see. Okay. So what is the gear ratio we're going for here? I see a lot of 24 tooth. 2 to 1. Okay. So that means our motor shaft is going to be a 24th, right? And then the output shaft is going to be a 12th.
Yeah, this is the driving gear.
Okay.
And then for the cap shafts, the ones with the little ends like that, you're going to want to add a washer right here where the cap is, because that actually creates friction because it's not as smooth as this, I guess.
So right after the cap, you want a
right
washer?
Right after the cap, yeah.
Okay.
You'll put a washer, so right here.
Okay, so the metal to the plastic contact is not good for friction.
Yeah.
Okay.
And one thing is for, this one is longer because this is the one that will be going to the wheel.
Okay. And why a cap shaft there, not a motor shaft?
Why a cap shaft? Because then motor shafts, they're not long enough for to go all the way through like a...
Or why not a normal shaft, you know? Why do we have to use cap shafts?
Because then this one, it can't pull out, like, can't pull it. The other ones, if you, like when you're turning a lot, your robot like moves out, and then sometimes your shafts, like ours, it comes out.
Okay.
But
so the wheel will never disengage in this case?
Yeah.
Okay.
But it's better for better to make sure that the only time the gear will stay in with the normal shaft is if it's rusted, and that will create a lot of friction. It won't spin as well.
Okay. So no rusted shafts.
No rusted shafts.
So store the shafts in a heated compartment. Okay.
And then always add another beam on the other side so it's closed off. So it's closed off on one end.
Do we need a washer here? Aha, I got him. So how many drivetrains have you built in your robotics VEX career, would you say?
Probably 6 to 7.
6 to 7 total or per year?
Total.
Total, okay. And you've learned a lot since then, right?
Yeah.
Since when you first started? Okay.
Yeah, when I first started.
Okay, so why'd you add this connector over here?
This connector will be going into our drivetrain, so it interlocks. And I'll go further in depth on that after this.
Cool.
So for gear trains, drivetrains, you always want to make sure they're both, like, there's a beam on both ends, because then it'll move around. Sometimes it'll go like halfway into the gear and it'll disengage. Okay. Also remember not to put too many washers. Because if you put too many washers, then it starts to become too thick and it starts bulging out.
Okay.
So that's just how it is. Okay, we finished our gearbox. Now we're going to move on to the drivetrain. We're going to connect it to the drivetrain.
Okay. So the one standoff you use, is that very general for the gearbox when you have a washer, gear washer?
For this, it fits perfectly. As you can see, there's very little movement. You always want a little bit of movement, because if too tight, then it'll create more friction than there already is.
Okay.
So we're gonna have this.
And where's this chassis from?
This chassis is from the Moonwalker, but modified.
Tough to put in, I guess.
Yeah, it is.
It's a good sign of a builder, right? The harder it is to take apart, the better you built.
Yeah.
These pieces are falling off. Okay.
I'll put it back. Okay. Okay, we're gonna connect this. So we have this beam here, and then this. Okay, so now we're gonna add the wheel. For our wheel design, we're gonna be using, for the perfect spacing, it is 1 washer, 3 spacers, 3 spacers, another washer, and then for our wheel design, right here, as you can see, in our wheel design here, if you put the shaft through, it'll wobble a bit because it's not supported on this side. So it's uneven and then it'll move a bit. So we use this piece like this, and we put a 2x2 with the
2x2 beam with a
shaft hole.
Okay.
And then we put it in like that with 4 standoffs and like that. And then it's now even. So
and that creates like a wall on both sides? Okay,
yeah.
Cool, so it's not cantilevered. Nice.
So then we're gonna add it in.
So would you recommend that for every wheel? Like a wheel hub?
Yeah, we use it for every
And what about the Omni wheel? Is it the exact
Yeah, we
same?
still use it. We have it in this one.
Okay.
And then we then use 3 spacers and then a washer. This is the perfect setting we found for our robot. But it depends on how big it is or how narrow it is, how many spacers you need. So yeah. And now I'm going to go on how I built the Moonwalker chassis and why is it strong. So here, look, it doesn't bend at all, basically, like this.
Can I see? Okay, so not much movement at all. Okay. And obviously not this way because the bars would not bend.
This is a prototype one. The new one, the other one is a lot stronger than this.
Seems very smooth. And that squeaky noise, is that a good thing or a bad thing?
That is the washers.
That's the washers, okay. Nice, okay. Okay, so what's next?
Okay, now we're going to be talking about how to use cross support beams. So here, this thing right here, it bends a lot. For our prototype, right here, it bends.
Okay.
How we solved this problem is we added standoffs here so that it wouldn't move in. And then we like cross supporting so that, look, so when
what do you mean by cross supporting? What does that actually mean?
So like the two beams meet at like a 90-degree angle, like right here.
So like a T? Or like this?
More like a L.
Like an L, okay.
Yeah, so like right here, this is an example.
So that's a cross support right here in the corner, okay.
So like this, so it's a lot harder to pull apart because then you have to pull diagonally. Because then you have to pull this out and that out. Okay. So it's much harder to break. Like inside here, we have this.
Yeah, I like what you've done with this, like this gray 2x2 connector here. You can't pull it out any direction, right? Because
because
it's
this
sandwiched
one
between two yellow pieces.
Protect it there.
Nice.
And then for back here, this is we use this. So we have
what is this?
So we have these two beams to prevent bending in, and we use these batteries and brain and the motors. The motors are one of the motors and brain are the strongest thing to use and to incorporate because they're the most solid. So when you incorporate it with your drivetrain, it doesn't bend in. Like right here, like this part's the most.
You treat it like another piece of like a plastic beam, basically, right?
Yeah.
It's like casing. Okay.
So if instead of having your brain on the side flopping around, creating like unbalanced weight, you can put it in the dead middle. And this, when you have all your motors and brain here, it creates a lot more equal low center of gravity because your robot's a lot lower and it turns easier. Okay. When you have a lower center of gravity, when you have a higher one, it's higher. It's harder for your robot to move.
And then this is somewhere where you put your gyro as well, right? Because that needs to be lower.
Yeah, you want to keep your gyro low because if it's high up, then it gets a lot more vibration from your robot. So when it's low connected to the robot, it's a lot better. Okay. And then for back here, we have this. We have an L connecting from the drivetrain at the wheel part itself, and then we connect it to a beam that goes from the brain to brain, and then we connect it together. So this part doesn't really come out. Okay. And then that's so
it's basically like what I see here going on is basically if you have an object where in order to pull it apart you have to pull in two different directions.
Yeah.
That's what you call a good brace, right?
Yeah.
Okay. And that's throughout your robot. Okay. Cool.
And then we have this, like we use the one beam below because then you can pull out the battery.
Shut up like that.
Yeah.
Okay.
So you can pull your battery out really easily, and then you can put it in because it's like a perfect spot.
Nice. And you have access to ports as well. Cool.
Yeah. And then you have easy access to ports. And then we leave little holes here so that you can build whatever you want on the sides.
And the wires to go there too, right?
Yeah.
Okay, cool.
Okay, so now I'm going to compare Moonwalker and our prototype.
Okay.
So this is Moonwalker.
So you want to take a look at the bottom? Okay.
Yeah.
So can we flip it this way?
Yeah, so over here you can see the two motors.
Yep.
And then there's another two here. So this is 4-motor drive, 3-to-1 gear ratio. And over here, like I said, the standoffs we would add, the cross support. And this one is really hard to bend. Like you really don't see much movement.
Yeah.
In it at all.
A lot of cross supports, like you'd say, right? Okay.
Yeah. So this brace right here we use to connect to this beam, which is connected to this beam. So these motors do not move. These are connected to these beams.
The tower. Okay.
Yeah. So all these things are connected interbrace, like brace. So like see this one connects to here, like an L again, like I said. And then it goes up. This one goes up, and then this is another L, like that.
Yeah.
And then we
a lot of L's.
Yeah, a lot of L's.
A lot of W's. Okay.
Yeah.
Cool.
And then
so that's the difference, right? And what about this side right here? Because I see different. It's a different connector.
Oh yeah. So these standoffs are a lot lighter, but they also like bend a bit. Like these ones are solid, and they don't move.
But it'd be a little heavier, right?
Yeah, they're a little heavier.
Okay. It's a worthy sacrifice.
Yeah, it is.
Cool.
And then for down here, we connected so that these beams connect to this, so this one doesn't move. And for this one, it comes out of it.
Okay.
So we prevent that in this robot, so it doesn't move out like that.
I see. But then this robot's also like finalized, and you know exactly where everything goes.
Yeah.
So you can
This is the final
finalize
version.
exactly. Okay. And this is still like a prototype version where you don't know what you're gonna put on.
We're still gonna improve it.
Okay. Cool. All right. So yeah, that was it, guys, for the video and building secrets and fundamentals with Tyler. And just like as you were to drop questions and comments in the live stream, drop your comments and questions in the comments below, and then we will answer them. Tyler will answer them, as many as he can. And yeah, we'll see you guys later. Bye.
Alrighty, I'm gonna get it. I'm gonna get it. Yeah. Kabang. So close. Try this again.
You're gonna hit him.
Kabang.
Let's go.
You got it.
All right, that's a good end to the video.